In this class, we are going to learn about the dimensional analysis students. Here in this class, you will learn about how to write a dimensional formula and what is the meaning of the dimension, okay, and what is the dimensional equation. And also, we write few dimensional formulas of numerous physical quantities students. Let's start the class. In earlier class, we have learned that we have two types of physical quantities. One is the fundamental physical quantities, and we name them as what? Mass is a fundamental physical quantity. Okay, students, and the length is one more fundamental physical quantity, and third, time is one more, and we are writing about the SI system of units here. Then after I said it is thermodynamic temperature, and the next one is quantity of matter, and luminous intensity, electric current. I said these are the fundamental physical quantities in SI system. Additional to that, we have two more. They are supplementary physical quantities. Here in supplementary, we have two. One is plane angle, and the second one is the solid angle. In previous video, we learned up to here. Okay, students. Today we will learn about how to write the dimensional formula. First of all, we have to understand what is the dimensional formula is. A dimensional formula explains us which physical quantities are involved in it and how they are arranged. A dimensional formula tells us which physical quantities are involved in that in that formula and how they are arranged. How we'll write the dimensional formula? Basically, we will take these fundamental physical quantities to write the dimensional formula. Most of the physical quantities have the mass, length and time terms. Additional to that, thermodynamic or quantity matter. Anything can be added. Okay, students. First, I am taking the first letters of three. These are the base units, base physical quantities. I am writing it as M, L, and T. Okay, students. M, L, T. Okay, it is mass, it is the length, and it is the time. And we have to learn how we have to arrange these physical quantities to get a dimensional formula. Okay, students. First, we are taking the length. Okay, students. What is length? Okay, it's a measure between the 2 points. We are taking length. The length can be written as like the students. Length is written as L power 1. In the same way, we have to write the mass. Mass can be written as M power 1. Okay, students. And time is T power 1. I'm writing the same here. Now I put the powers. These powers are known as the dimension, students. Okay, students. What are these powers? Powers are known as the dimensions. What is the dimension? Okay, the power to which the fundamental physical quantity is raised. Dimension means the power to which the fundamental physical quantity is raised. Okay, students. Power means what? Sorry, dimension means what? Dimension means the power to which the fundamental physical quantity is raised. If you have the time, please note these definitions, students. Okay, what is meant by the dimension? Dimension means the power to which the fundamental physical quantity is raised. We learn that physical quantity. What is the physical quantity you have learned? And what is the fundamental physical quantity? Any physical quantity which doesn't depends upon other physical quantity is known as the fundamental physical quantity, students. A physical quantity which doesn't depends upon any other physical quantity means what? It has its individualness with it. It has its individuality. For example, you take the mass. Mass is a fundamental physical quantity, students. Means mass doesn't depends upon any other physical quantity like length and as well as the time or the thermodynamic temperature or any other. What does it mean? The mass remains constant everywhere. Mass doesn't depends upon any other. It doesn't depends upon time. If 1 kg mass we kept somewhere, it will be 1 kg only for coming hundreds years, hundred of years, or thousand of years, or 1 month, or 1 day. It doesn't change by own. And the second thing, time is also a fundamental physical quantity. It doesn't change. You can't get the time 8 o'clock here, where you are listening the lesson, or somewhere it might be 9. It doesn't. In the same way, length. If I am a height of 5'7" here, I should be 5'7" at anywhere. Okay, students. It doesn't depends upon any. If a thing becomes big, the length of the thing doesn't change. Okay, students. That's why we call it as the fundamental physical quantity. Here, what is the dimension? The power to which the fundamental physical quantity is raised. Okay, students. That means what? Mass is written as, I wrote it as m power 1. M power 1. This is the dimension. This is the dimension. Okay, students. And this one is the physical quantity. Physical quantity. Are you understanding, students? Okay, students. M is physical quantity, its power is dimension. If it is written as m square, for example, again, the square is the dimension and m is the physical quantity. For example, you take the length, L power 1. This one is the dimension and L is the physical quantity. If you write it as the L square, 2 is the dimension and L is the physical quantity. I think you are understanding what is the power is. Okay, the power is nothing but the dimension, students. Dimensions are the powers to which the fundamental physical quantities are raised in. I hope you understood. Okay, students. If someone asks you to write the dimensional formula of mass, okay, students, basically we involve all the physical quantities to write a dimensional formula. I mean, the base units are what? Base physical quantities, mass, length, and time. Okay, I am writing the dimensional formula for mass, students. Dimensional formula. Shortly, I am writing it as DF. I told you dimensional formula is the which explains which physical quantities are involved in it and how they are arranged. How they are arranged means the powers. How the powers being arranged. Okay, students, I'm writing the dimensional formula of mass. Okay, mass, I'm taking the first letter m, its power is 1. Okay, next I'm taking L and T. Generally, we represent a dimensional formula with all the base physical quantities M, L, T. Is there any length in the mass? No. It doesn't depend upon length. Mass is mass only. We can't say only 10 centimeter of mass. Length has the mass. Okay. Anything has the mass. In the same way, I already discussed the time. With time, the mass of the body doesn't change. If you keep 1 kg of sugar here, it could be 1 kg for coming years if no one touch it. Isn't it, student? It is the dimensional formula. It is the dimensional formula. See, students, in the same way, we are writing the dimensional formula of length. Okay, students, how we'll write? The same trick we have to write M, L, and T. This time, mass is 0, length is 1, and time is 0. Okay, students. And similarly, dimension formula of time. We have to choose all the physical quantities here, M, L, T. Then we have to put the powers. M, 0, L, 0, and T is 1. Maybe in examination it will ask you, what are the dimensions of mass, length, and time in the dimensional formula of time? What are the dimensions of mass, length, and time in the dimensional formula of time? Simply have to write. Mass has the dimensions of 0, length has the dimensions of 0, and time has the dimensions of 1. Okay, students. The same could happen here. The dimensions of mass is 0, length is 1, and time is 0. Here also 1, 0, 0. In that way, we will write the dimensions. Let's go with few more dimensions here, students. Okay, students, I hope you are understanding. If you listen to the class, further you will understand how to write the dimensional formula and what is the dimensional equation and what are dimensions also. Okay, students, we are writing a list of dimensional formulas. First we start. Already we learned about the length. Okay, students, if it is the length, we wrote the dimensional formula as M0, L1, T0. Okay, students, and we mentioned the dimensions as 0, comma 1, comma 0. These are the dimensions. Okay, students, then we take the mass. Mass, you know that. M power 1, L0, T0 means what? What are the dimensions here? M1, comma 0, and 0. Then we take the time. Time can be written as what? M0, L0, and T1. And the dimensions are 0, comma 0, comma 1. I think you are understanding now, students. Now we'll write the dimensional formula of one more physical quantity. Here I am writing the dimensional formula of area. Okay, students. Area is a derived physical quantity, students. Now listen my words carefully. I said fundamental physical quantity is a quantity which doesn't depend upon any other quantity. It is individual. Okay, it is individual. And what is the derived physical quantity? The physical quantity which depends upon other physical quantities. Derived physical quantity means what? Derived physical quantity Okay, what is the derived physical quantity? The physical quantity I am writing shortly, which depends upon other physical quantities. Let's see how it is. Okay, area. What is meant by area, students? See, I'm taking a square now. Take it as a square. Okay, square means what? Okay, it is the length and breadth. Okay, here, if it is a square, it is the square. You learn that in case of square, length is equal to breadth, is it? And we can write the area of square. Area of square A is equal to length into breadth. Okay, students. Here I said length is equal to breadth. Then it can be written as L into L. That is L square. Okay, students. No mass is involved in it. No time is involved in it. Only length is involved. Now we are writing the dimensional formula. Okay, students. I said symbolically we represent three physical quantities in a dimensional formula. That means what? We have to take mass, length, and time. See the students. Mass, this area is not at all depends upon the mass. That's why we are writing the power. That is dimension is 0. And length, see. Length is of 2 times. That is square. And time is 0. Okay. It is the dimensional formula of area, students. See. M0, L2, T0. And what are the dimensions? Watch it. 0, comma 2, comma 0. It is about the square, students. Now we are taking a circle. Okay, I'm taking a circle. It's a circle. And you know that circle has the radius and the area of circle, the length, area of circle is pi into r square. Here radius, r is the radius, students. Radius is length only, isn't it, students? Then you can write radius or as L and okay, students. Now we have to write the dimensional formula. Here you have to ask me, it has the pi, where you left the pi cell. I didn't left. Pi is a constant, students. Pi is a constant. Pi is a constant. Constants and numbers, that whatever the number is, 3, so on. It is a number. Don't have any dimensional formulas. Okay, students. Is constants and numbers. Not all the constants, few constants. Don't have any dimensions. That's why we are neglecting the pi, since it is a constant. Then what we got here? Area of the circle can be written as pi r square. Pi r square means what? It has only length. Then again, we'll write the dimension formula. Dimension formula is what? Length into breadth. Here we have the r square. R is nothing but L, that is L square. And the dimensional formula is M0, L2, T0. And the dimensions 0, 2, 0. Compare with the students. Area, whatever the area is, what's the area of the circular patch or a square or a rectangle. For example, you take the rectangle. Okay, it is the length, and the breadth. Obviously, length is length only, and breadth is the length. We get the same thing. Understanding, students? I hope you understood how to write the dimensional formula of a derived physical quantity. Let's go with one more, students. Okay, we are getting the dimensional formula of volume. What is volume, students? You learn that volume is nothing but length into breadth into height. Volume means what? Length multiplied with the breadth and height, students. Okay, then the dimensional formula of volume can be written as, here we have to take the m to the power of 0, L. If L is equal to B is equal to H, you can write it as L cube. I'm writing it as L cube. The time is 0. Okay, students. And what are the dimensions? Dimensions are 0, 3, 0. Maybe the question will be asked like this. What are the dimensions of length in the dimensional formula of volume? What is the dimensional formula of volume? M0, L0, T0. What are the dimensions of length? Obviously it is 3. What is the dimension? Power to which the fundamental physical quantity is raised. Now let's do one more. Already we found the dimensional formula of length. Okay. Length is what? M0, L0, T0. Okay. Mass as M1, L0, T0. Time as M0, L0, T1. Okay, students. And we got the dimensional formula of area. Area we had it as M0, L2, T0, and volume. Volume is M0, L3, T0. If you want to note these, students, please freeze the frame and you can write the dimensional formulas. Okay, students. Next we are writing the dimensional formula of one more derived physical quantity. Okay, before that we will write the dimensional formula of displacement. Dimensional formula of displacement. And you have learned that displacement is the shortest distance between the 2 points. Let's say it is the path, say it is A and it is the B, then this one is displacement, shortest measured length between the 2 points. It's nothing but the length, students. But displacement is a vector. Displacement is a vector. And in next videos, you will learn about the vector physical quantities. If you are eager to know about the vectors, go to my channel. You will get around 14 videos about the vectors and students. Here, most of the topics are covered in those videos. If you like, please go through. Okay, students, it is the displacement. We are writing the dimensional formula. Displacement is nothing but length, I said. What's the dimensional formula? That is M0, L1, T0. Displacement is nothing but length. That's why I got. In the same way, the length. Length means what? The measured length between the 2 points. Okay, it is the distance, students. Here we are writing the dimensional formula of distance. Distance do have the same dimensional formula since both are lengths. That is M0, L1, T0. Okay, students, we covered the displacement. Then the next physical quantity, which is a derived one, and you know about this, that is velocity. What is the mathematical relation for the velocity, students? Actually, velocity is a derived physical quantity. Additional to that, it is a vector quantity, students. A vector quantity is always represented with arrow on head. Okay, students. If the V is a physical quantity, if you keep an arrow over the head, it represents a vector. Okay, velocity. How can we define velocity? Rate of displacement means what? Displacement upon time. Okay, students. Displacement is nothing but length. We have to write it as L upon T. Okay, students. And what is the dimensional formula? Dimensional formula can be written as L means L power 1 being taken up, then it is L inverse. To write the dimensional formula, generally we use the three physical quantities in mass, length, and time. Here, mass, no mass in velocity, but length has the dimensions of 1 and time has dimensions of minus 1. See, till now we went through the dimensions which are only zeros or the plus. Now, negative dimensions we are writing. We wrote the zero dimensions, then after the positive dimensions. Now, we wrote the negative dimensions. What are the dimensions? 0, comma 1, comma minus 1. Okay, students. Velocity is over. Then we go with acceleration. And you know that acceleration. Did you experience acceleration in your life, students? Generally, we go through the acceleration in daily life. Vehicles provided with accelerators. People generally call it as the accelerator, but it is the accelerator. What is the accelerator? It increases the speed of the vehicle, students. It increases the speed of the vehicle. Bikes do have the accelerators. Just think, for us, what are the accelerators for a human? Obviously, our legs. If we make the legs to run faster, we have greater acceleration and as well as the velocity. And if you start reducing your speed in given time, you are retarding. Okay, students, acceleration means what? Velocity upon time. Velocity upon time. Acceleration is shown with the letter A. It is another physical quantity which is a vector, students. Velocity by time. Okay, students. Velocity means what? Length upon time, already we wrote there, by time. That is length upon square of the time. Then you can write length t power minus 2. If you represent it as dimensional formula, we are involving mass also. That is m0 L1 t minus 2. Okay, students. Whatever the acceleration is, it is the acceleration, retardation, or acceleration due to gravity. It has the same dimensional formula. Just we have to add the word before. Acceleration due to gravity. Retardation. Okay, students. And what are the dimensions are here? 0, comma, 1, comma, minus 2. See? We are getting the negative dimensions here. 0 dimensions, positive dimensions, and as well as the negative dimensions. Maybe the question will be asked like the students. What are the dimensions of time in the dimensional formula of acceleration? Obviously, it is minus 2. Okay, students. Let's go with one more physical quantity. Okay, students. I hope you are understanding and you noted all these things. Okay, volume, and we got for velocity what we had. For velocity, we got it as m0 L1 T inverse, and acceleration. It is m0 L1 T inverse. Okay, students, I hope you understood how to write the dimensional formula till now. And I'm writing one more dimensional formula for a derived physical quantity. That is force. That is force. Force is one more vector quantity, students. Force is one more vector quantity. What is the force? Mathematically, we can treat the force as the product of mass and acceleration. Mathematically, we can write force as mass times to acceleration. Force means mass multiplied with the action. But we have to define it as, okay, we have to define the force as force is that which changes or try to change the position of the body. Force is that which changes or try to change the position of the body. Simply we can say force is a mischievous thing. And what is its characteristic? If a body is resting, it tries to move the body. If the body is moving, it tries to stop the body. Understanding, students? We have to write the dimensional formula for force, students. Okay. The dimensional formula of force is what? Mass means you learn that m1, l0, t0. For acceleration, we are borrowing from here. It is m0, l1, t inverse 2. Okay, students. Then we can write the dimensional formula as these are the bases. If the bases are same, we have to add the powers. M to the power of 1 plus 0, L to the power of 0 plus 1, T to the power of 0 minus 2. 1 plus 0 is equal to 1, M1, L1, T inverse 2. It is the fastest way to write the dimensional formula, students. In other words, you can write the dimensional formula. Mass is m and acceleration is what? Velocity by time. Okay, students. Then you can write mass as m1, l0, t0 multiplied with velocity. Already we had m0, l1, t inverse 1 by m0, l0, t1. We are doing the same here. M to the power of 1, L to the power of 0, T to the power of 0, and m to the power of 0, L power 1, T inverse 1. I am taking these up. It is m to the power of 0, okay, L to the power of 0, and T to the power of minus 1. Again, we are taking the same physical quantities which have the same base. That is what? M, it has a power of 1 plus 0 plus 0, L, 0 plus 1 plus 0, T to the power of 0, okay, minus 1, minus 1. We get the same thing. M to the power of 1, L to the power of 1, and T to the power of minus 2. See, what we had here, the same can be, okay, formed by using this relation. Force is over, students. Then after, we are going with one more physical quantity, which is work or energy. Okay, students. Now, we are writing the dimensional formula of work. What is work? Force multiplied with the displacement, students. Force multiplied with displacement. It is a mathematical relation, students. Actually, you have to write or define the work like this. By the application of the force, if a body gets displaced, displacement means what? Has to move along a straight line. Then work is said to be done. By the application of the force, if a body gets displaced, the work is said to be done. That means force has to displace a body. Yeah, that's why I wrote force, okay, multiplied with displacement. Okay, the dimensional formula of work is what? Force is mass into acceleration. Displacement means S. Mass means I am writing the dimensional formula. M1, L0, T0. For acceleration we are borrowing M0, L1, T inverse 2. Displacement is nothing but length. That is M0, L1, T0. We are doing again the same what we did before. M to the power of 1 plus 0 plus 0, L to the power of 0 plus 1 plus 1, T to the power of 0 minus 2 plus 0. And finally we read m to the power of 1 L2 t to the power of minus 2. Then see the powers 0, 2, minus 2. These are the dimensions. Okay, students, it is the dimensional formula. And remember, students, work and energy have the same units and as well as dimensions. Wherever you will find the energy, its dimensional formula is m1 L2 T inverse 2. Okay, students, what type of energy it is? Okay, we should not worry about that. It is electrical energy, heat energy, sound energy, whatever energy. Okay, potential energy, kinetic energy. Anything has the same dimensional formula, students. This is the way to write the dimensional formulas. The two, I gave few physical quantities for you. We completed the work. Okay, acceleration. Then after we got for force, it is m1 L1 T inverse 2. Okay, students. And we got a numerous physical quantities there. Okay, understanding, students? I hope you are understanding. And we go with one more. Okay. Now we are writing the dimensional formula for few constant, students. Dimensional formulas of few constants. Some constants don't have dimensional formulas. I showed before. Okay. Numbers and as well as the few constants. For example, you take a equation, students. It is the equation for the energy, students. Energy is equal to H into nu. What is E here? E is energy, students. H is Planck's constant. You will learn about this thing in coming study, students. Planck's constant. And nu means frequency. Nu means frequency. What is the frequency? Reciprocal of time. Reciprocal of time period, students. And you know that time period or time are same. That means what? It is 1 by t. Okay, students, we have to write the dimensional formula. Energy. Okay, you learn that. H is equal to E by nu. We are writing the dimensional formula of constant. That is what? Planck constant. Okay, students. Here H is the Planck constant. You know that energy has a dimensional formula of what? Earlier we derived, that is m1 L2 T inverse 2. By frequency, I said it is 1 by t. Take it up, you will get m1 L2 T inverse 2. Okay, it's going on. It becomes t. Okay, students. Then it can be written as m1 L2 T inverse 2 plus 1. And finally we can write it as m1 L2 T inverse. Say, students, m1 L2 T inverse. Then the dimensions. What are the dimensions? 1, 2, comma, minus 1. Okay, students, now we are writing the dimensional formula for one more constant, students. That constant is known as universal gravitational constant. Universal gravitational constant. Okay, students. What is this universal gravitational constant? Generally, this constant is shown with the letter G, students. Okay, this universal gravitational constant explains about the force acting between the two bodies. Let's say it is the mass m1 and we had one more mass m2. They have been separated by a distance of d. Okay, students, I am joining the sentence. Then a force acting between them along this line, students. This force depends upon the two factors, students. One is the mass of the body, directly proportional to mass of the bodies, and inversely proportional to the square of the distance between the centers. Then we can write it as 1 by d square. If we write together, we can write it as F is proportional to m1 m2 by d square, or F can be written as G into m1 m2 by d square. Okay, it is a formula for force acting between the two bodies. See, students, universal gravitational constant is useful to find the force between two bodies. That means in universe, every two bodies are attracting with each other. Every two bodies are attracting with each other. Here two masses we took. Maybe it is the sun or the earth or moon or you or me. Okay, students, these are the masses. They being separated by a distance of d. Then force is directly proportional to the product of their masses and inversely proportional to the square of the distance. Together, they can be written as like this. Okay, we have to write the dimension formula for G, students. G can be written as, okay, I'm multiplying this, F into d squared by m1 m2, where F is force, students, and length, the dimension of formula of force is m1 L1 T inverse 2. Already we derived. And D is what? Length, students. Okay. Length means what? M0, L1, T0, and M1, M2. M is mass, students. Mass we derived M1, L0, T0. We have to put all these things here. That is, G can be written as F. We had it as M1, L1, T inverse 2, multiplied with, what is that length? M0, L1, T0, and it is squared, see this, upon M1, M2, M1, L0, T0, multiplied with M1, L0, T0. Further, it can be written as, students, M1, L1, T inverse 2 into m to the power of 0 into 2, that is 0, L squared T0 by m squared L0 T0. Further, it can be written as M1 L1 T inverse 2 multiplied with M0 L2 T0. I'm taking it up and it becomes m to the power of minus 2 into L to the power of 0 T to the power of 0. Then we are taking the bases. Here bases are same. We have to add the powers. M to the power of 1 plus 0 minus 2. L to the power of 1 plus 2 plus 0. T to the power of minus 2 plus 0. Okay, students. Plus 0. Then it can be written as m L to the power of 3, T to the power of minus 2, or m inverse LQ T inverse 2. M inverse LQ T inverse 2. Okay, students. And what are the dimensions? Minus 1, comma 3, and minus 2. Listen, students. This dimension formula has its own speciality. It is only one physical quantity in entire mechanics which has the negative dimensions of mass. Remember this. Universal gravitational constant is one and only physical quantity which has negative dimensions of mass. See, the mass dimensions of mass is minus 1. It is a very important question for the competitive section students. I hope you enjoyed the class. If you like my video, please forward to your friends and don't forget to subscribe it and go for a life. Okay, students, let's we meet in next video. That could be the extension of this one. That means we will write some more dimensional formulas for different kinds of physical quantities.